Hello everyone, this is part 1 of combinations. In this session, we will learn what are combinations and calculating number of combinations in a given scenario. Please refer to the following link to get complete videos of the channel. Combination is defined as the number of ways of arranging or selecting a smaller or equal number of things from a collection of things with the order of selection or arrangement is not important. In simple words, we can say that if we want to select R objects out of N, then its combination is given by NCR, where the order of selection or arrangement is not important. So NCR is given by N factorial by N R factorial into N minus R factorial. In simple words, combination comes into picture when the order of selection or arrangement is not important, whereas in permutation, order of selection plays a role. But let us consider one simple example based on combinations. Out of 5 pens, I want to select 3 pens. So the number of combinations are given by 5C3, which is equals to 5 factorial by 3 factorial into 5 minus 3 factorial. So where the order of selection is not at all important. Let us look into different scenarios to calculate number of combinations. Here, given condition is the number of ways of selection of one or all objects. One or all objects out of total of n objects is given by 2 to the power of n minus 1. If you want to select one object out of n objects, it is given by nc1. If I want to select two objects, then it will be nc2. For 3 objects, it will be nc3 and so on ncn. So its value is given by 2 to the power of n minus 1. If the scenario is where I want to select 0 or all objects, then number of combinations are given by 2 to the power of n. So this is when we want to select 1 and this is when we want to select 0 or all objects. Let us look into an example based on this number of combinations. In how many ways we can select a player or all the players from a group of 9 players. If you look at this question here, n is equals to 9. Therefore, number of combinations are 2 to the power of 9 minus 1 as we want to select a player or all the players. If the condition is to select all the players, then it will be 2 to the power of 9. Let us look into one more scenario. Let us solve one question in order to understand one more different scenario. Here, find the number of ways in which 4 players can be selected from 8 players so that 2 particular players are always included. Without any condition, the selection of 4 players out of 8 players is given by 8C4 according to the definition of combination. But here the condition is 2 players, particular players are always included. That means now the selection is for 4 minus 2, that is only for 2 players we have to select. Now what about total number of players? Already 2 players are chosen, so the remaining players are 8 minus 2, that is 6 players. So now from 6 players we have to select 2 players, so which is possible. The possibilities are given by 6C2. So from this we can say that in general out of n objects, if we want to select R objects such that P objects should be always included, then number of combinations are given by n minus P as P objects are already chosen, C R minus P. If the scenario changes to out of n objects, we want to select R objects such that P objects should be always excluded. That means now total number of objects are reduced by P, that is n minus P C, out of which we have to select R objects. So n minus P C R. Let us look into some important standard results which are useful to solve numericals. First one, NC0 is equals to NCN and its value is 1. Second one is NC1 is equals to N. Third one, NCR plus NCR minus 1 is equals to N plus 1 CR. These are useful to solve numericals. And if NCX is equals to NCY, which implies that X is equals to Y. Or we can say that X plus Y is equals to N. So these are very much useful to solve numericals. In next session, we will discuss questions based on combinations. Please subscribe to our channel for latest updates. Thank you for listening and have a nice day.